Welcome to my physics class. In this lesson, we are going to look at a topic in Form 4, floating and sinking. We want to start with floating. And for us to do that, we need to state the law of flotation. Then we are going to apply the law in working out a question. The law of flotation states that a floating body displaces its own weight of the fluid in which it floats. In other words, when an object floats, for example, in water, the object will sink to a given level, and by doing that, the object will displace a given volume of water. So what the law says in this case is that if that volume of water was to be weighed, the mass of that water displaced will be equal to the mass of the object that is floating in that water. And I've used water here as just an example. Objects can float in any liquid or even in a gas. So when we are talking about a fluid, we mean liquid or gas. We would like also to mention here that the volume of the part of this object that is in the fluid equals the volume of the liquid that is displaced. So two important things. One, a floating body will always displace an amount of fluid, whether liquid or gas, whose weight will be equal to the weight of that body. We want to look at an example now. The example is already on the board. We can go through it together so that we see what the question requires. We are given a wooden block, and the measurements of the wooden block are given. The length is 10, the width is 5, and the thickness of that wooden block is 2 centimeters. On the other part of the board, I've done a little sketch to give us a visual image of the kind of block we are thinking about. And we are told that this wooden block floats with a half of its volume under water. So half of the body is submerged. The water has a density of 1.2 gram per cubic centimeter. Looks like it is seawater. And we are required to calculate the weight of the wooden block. We will start by getting the volume of liquid displaced, the volume of the water displaced. That's what we can. So we have the volume of the water displaced. That's what we are going to get first. And the question states clearly that the object floats with a half of its volume under the water. Therefore, we need to get the volume of the block and then divide by 2 so that we get the volume of liquid that is displaced. That's the water. So volume, we can use the formula for volume: length times width times height, and therefore it's going to be 10 by 5 by 2. And because we are told it's a half, then we are going to divide this by 2. We work out that and we get 50 cubic centimeters. Let's go back to the law of flotation. A floating body displaces its own weight of the fluid in which it floats. So we need now to get the mass of fluid displaced, the mass of the water displaced. we can go now back to the formula for density. We know it, density equals mass over volume. And now that we want mass, it is going to be volume of water displaced multiplied by the density of the water that is displaced. And so we get the volume is 50 cubic centimeter. The density is here. So the mass of water displaced is 60 grams. So again, going back to the law, a floating body displaces its own weight of the fluid in which it floats. The same, we could say, displaces its own mass of the liquid or fluid in which it floats. We've gotten the mass, but so that we are in line with the law completely, we will need to convert this now to weight. And therefore weight we remember that weight is mass times pull of gravity. And now that we have the mass in gram, we must remember to convert that to kilogram and then multiply by the acceleration due to gravity. So the weight of the fluid displaced equals 0.6 Newton. And going back again to the law, a floating body displaces its own weight of the fluid in which it floats. So the weight of the fluid displaced is 0.6 Newton, and therefore we know now the weight of the block is also 0.6 Newton. So we are going to stop here, and for your assignment, for you to see whether you followed what we have done. Suppose the same block was floating in ethanol of density 0.8. Would its weight change? What would change in this case? So work out that and then subscribe so that we can continue discussing this. In the next lesson, we are going to look at Archimedes' principle.